Hi friends, today let's discuss about the Singleton design pattern. Okay, let's go step by step. What is the what is the Singleton design pattern? First of all, Singleton design pattern comes under the creational design patterns. So as you all know, we have creational, structural, and behavioral. So under the creational, we have it's the Singleton design pattern. So this under the creation, it basically we see how the way the creation is being handled under this the creation design pattern. So this is one of the topic related to the Singleton design pattern. So let's build a motive behind this Singleton design pattern, and let's then go to the code, how this is being implemented. So so what do you mean by Singleton design pattern, uh, and how the Singleton design pattern will be used in the real time use cases? Okay, let us imagine if we have connections. Imagine if you have some database connections. Let us say some we are sending some request to the database to get some connections. Okay, so you have basically sent a request to give a connection. Let us say one connection. Okay, and if you know the concept of connection pooling, so it will manage these connections in these connection pools. Let us say C2, C1, C3, C4. Okay, so when you ask for the connection, it basically keeps these connections in the connection pool in order to effectively manage the memory or the connections, number of connections within the pool. So in order to effectively manage the connections, why we need to effectively manage means because connections are basically a shared resource. Connection is basically shared resources. It will be used across by different clients or different instances, you can imagine. Okay, so that is the reason why this is a shared resource. Let us say if one service wants to use a connection, it takes from the connection pool. Okay, for example, let us say request 1 is hitting, and it basically gives you the C1. Once it finishes the use, once the C1 the connection gets utilized, then it will basically keep it again in the same connection pool. Okay, so that is the thing. And the other thing is basically to it is kind of like a shared resource. So that is the one more thing. Now what you can say, okay, so one is basically to improve the memory utilization, and to performance and inconsistencies. So so here, why do we need to maintain the Singleton instance here? So the first thing is better memory utilization and better performance, and in order to avoid inconsistencies, because inconsistencies means this. For example, let us say if it is not Singleton, the same copy can be used by the multiple persons, or it can be used by the single persons. Okay, so whenever you are dealing with client server, uh, so client server mechanisms, you can expect uh, multiple sessions. You can expect multiple sessions, and also you can expect multiple requests. So you can expect multiple requests as well as multiple sessions, right? So when you are dealing with multiple requests and multiple sessions, for example, if you refresh, like one instance of the browser tab, or between the user login and logout period, there will be several instances, because when you are dealing with these client server mechanisms, you'll be having multiple sessions, multiple number of requests, and multiple users. All these combinations cannot have multiple copies, right? If you have multiple copies, then there will be a dirty reads. You will not know what copy has performed which operation, which copy. You basically need to track all those operations in which when you have same copies. So in order to deal with that, basically they came up with this Singleton design pattern. So I hope you understood this, right? So now there is also one more scenario where we have threads. So threads also basically will be having a shared resources, right? Shared resources. You cannot create multiple instances of multiple multiple copies of the threads, because threads also have the same concepts of thread pooling. It will also make use of thread pools when multiple threads are being created under a process. For example, in a process you will be having multiple threads, right? So these threads also basically needs to be handled with the singleton pattern, because again these also will be keep and these threads will also be being kept under the task thread pool to effectively utilize the memory and to avoid inconsistencies. Okay. And the third thing is logging. Okay. Logging also basically needs to have a singleton pattern, because if you don't have singleton in the logging, one person, it will be ending up in creating multiple instances. For example, let us say we are writing files. Okay, it will end up in creating 2 files. Okay, so because it's like creating a multiple copies, right? It will, if you are not allowing to control the instances, basically it will try to create multiple copies, and it for example, if there is a matter if there is a content which needs to be written in this file, some part will be 50% of this matter will be written in this file, or 50% of the matter will be written in this file. So kind of like inconsistency, or we can say these kind of things as dirty reads. Okay, so that is one thing. And so these are the things. Okay, so now Now in the interview they may ask, they may ask, why can't you use a static class instead of creating a singleton class? So because static class also creates a single instance, right? But they can ask that why can't you make use of the static class? Okay, let us imagine. Okay, let us see. Let us create a class logger. Okay, imagine you have this static class to basically create a logging. Okay, so this is basically using static class, and this is basically using a non-static class. If you go with non-static class, so I am creating a private constructor. So you basically check if instance equal to null, then you are saying return new, or else you can simply say instance equal to new SL. If it is already there, you can just return it. Okay. So if you see the difference between both of them, okay, so this is basically a static, you see a difference between both of them. So in the first case we are defining a static class, and we have a static read-only lock object, and basically we are you know um, having one method, log method. So the problem with the static class is you cannot instantiate the static class. Okay, static class is one-time memory initialization. So once the memory is created during the loading time, it will be unallocated. I mean, it will be freed up only at at a time, at a single shot, while the application kind of like and when the application unloads. But non-static class is not in that way. So non-static class is basically used to create multiple instances as per the demand of the user, or basically an on demand. So this is basically created on the heap area. So that is why non-static objects are basically meant for creating, to handle the state of the object, because the state of the object may change over the period of time, right? The state of the object may change over the period of time. It is not fixed. So that is the reason why we go with non-static classes. So if you see here, this is a sealed class. Okay, within the sealed class you have a instance variable, you have a so all these are static variables, and you have a private constructor to make sure nobody creates nobody initializes the object of this class. And finally you have a static method to get the instance. So basically it will check if the instance is null, it will create a new instance for you, else it will return the existing instance. And also to avoid the concurrency issues, you are basically putting a lock on top of that. Okay, and you are writing basically you are having a method here to basically implement the logging. Tomorrow if somebody wants to inherit, let us say if tomorrow, okay, so imagine if tomorrow, imagine a case where so this is a singleton logger, right? So I have removed the seal here, okay, and instead of private I am keeping the protected instance, so that tomorrow if somebody wants to extend this class, he can easily extend it, and he can write his own, he can write his own logic here, or he can override the if he has an existing log functionality here, he can override it here. Either he can implement, or so this is the flexibility which we have with the non-static classes. But with static classes, it is kind of like a use and throw. The memory initialization will be only one single shot at a time, and once it is done, you basically need to, so it is done, so done there. So that is the main purpose of this singleton design pattern. I hope you understood all the scenarios of how the singleton design pattern is what is the motive behind this singleton design pattern, what are the use cases. First we gone through the connections, how the connections are being what is the use case of connections, why the connections are singleton, because these are basically shared resources. And in order to avoid the inconsistencies, whenever there is a client server model, you will be having multiple sessions, multiple requests, and multiple users creating different instances. So these instances cannot be copies. right? So because if one person cannot have I mean um, because these things, whenever there is a shared resource, it should be consistent across all the different locations, or it should be consistent across the locations or across the users, because one user should not have one data and another user should not have another data. So that is the main thing. So that is the reason why they came up with the singleton design pattern, and how it is being utilized with respect to the connection pool. We have discussed that. And threads also kind of have the same concepts of thread pooling, and how the shared resources, like threads, make use of this thread pool via the singleton to create effectively the threads via the processes. So under the process, you have basically in an operating system, basically under the process you will be having different threads. So these threads are basically costly operations, because creating a thread, it requires memory utilization, because basically if you see the CPUs, you have single core, multi-core. So within this multi-core, you will be having different processes, right? So if you open the task manager in your PC, let us say you have IAS, there will be a separate process for that. For example, if you have some other things, Word, if you open a Microsoft Word, it will be running under the different process. So under that process, you will be having different threads to handle multiple tasks. So these are basically a costly operations, right? So you cannot simply have duplicate copies, and you cannot corrupt the data. So that is the reason why the singleton pattern also will be used in this scenario. And third thing is logging. So under the logging, you cannot create multiple files. So as I said, it will be kind of like a dirty reads. So the write operations on the file should be consistent. So once it is done, only then the next operation should be performed. And also mind you, when performing these operations, multiple threads or multiple requests also can come to manipulate the data. So that is basically what we call as dirty reads. So that is the reason why we are putting a log here. Okay, if you see, so to handle the multiple threads or multiple requests, to process concurrently, so we come up with these threads. So I hope you understood the motive behind singleton design pattern. And let's see the code implementation, how it was implemented. Okay, thank you.